Okay, so good day everyone. So let us proceed now to the chapter 3 under the mathematics in the modern world. That is what we call the problem solving and reasoning. Okay, so for that, so we have here the objectives under this chapter. So we have here letter A, understand the inductive and deductive reasoning. Letter B, differentiate mathematical induction to certainty. And letter C, state the steps of problem-solving strategies. So for that, let us start now in the first lesson or the lesson 1 under this chapter 3. So that is the inductive and deductive reasoning. So for that, so let us start with inductive reasoning. So inductive reasoning, it is the process of getting a general conclusion by observing the specific example or set. Or just simply if we say inductive reasoning, so we will start from the specific conclusion going to the general conclusion. Now, for that, so we have here an example in regards to inductive reasoning. So example, so use inductive reasoning to predict a next number. So we have here class the numbers 3, 6, 9, 12. And then what is the next number? So for that, so we're dealing with this solution. So each successive number is 3 larger than the preceding number. Thus, we predict that the next number, that 3 larger than 15 is 18. So meaning, if you take a look the pattern, which is 3, 6, 9, 12, and 15, so if you notice, so the common difference of every preceding number is 3. So that's why we will come up with the next answer or the next number that is equivalent to 18. Okay, now another example in regards to inductive reasoning. So example number 2, so use inductive reasoning to predict a number which is 1, 3, 6, 10, and 15. So for this one, or for this set of numbers, so we will come up with this solution. So the first two numbers differ by 2, then the second and third number differ by 3. It appears that the difference between any two numbers is always 1 more than the preceding difference. Since 10 and 15 is differ by 5, then we predict that the next in the list will be 6 larger than 15, which is equivalent to 21. Now, if you notice again the set of numbers, we have 1, 3, 6, 10, and 15. So if you notice again, so we have here the pattern, which is 1 more than the preceding difference. So meaning, if we come up with that kind of pattern, so we will have the final answer after number 15, which is number 21. Okay, because of the pattern, 1 more than the preceding difference, or just simply the common difference will added to the value of 1. Okay, so that's why the next number will become 21. Okay, now how about the deductive reasoning? So in deductive reasoning, it is the process of reaching a conclusion by general assumption. Okay, then procedures and principles. It is distinguished from inductive reasoning since deductive reasoning is finding conclusion by applying the general principle and procedure in the observation. Or meaning, we will come up first with what we call the general argument going to a specific conclusion. And then will lead us into logical truth or just simply a realistic truth. So that is the deductive reasoning. So again, we will come up first with a general argument going to a specific conclusion. Now, we have here some examples in regards to what we call the deductive reasoning. So use deductive reasoning to establish a conjecture. Now, if we say conjecture, so meaning that is not proven. Okay, if we say conjecture. Now, use deductive reasoning to show that the following procedure produces a number that is 4 times the original number. Now, let us have the procedure. This one. So we have here the procedure. So pick a number. Then after that, you need to multiply the number by 8. Then add 6 to the number or add 6 to the product. And divide the sum by 2. And the last one, we will subtract it by 3. So now, for this procedure, so we will come up with this solution. Okay, so first, we will let n as the representation of what we call the original number. Okay, so we will let n again as the representation for the original number. And then again, we will come up with the first procedure. So again, after picking a number, then after that, multiply the number by 8. So again, n is our original number, and then we will multiply it by 8. So you will come up with this. It will become 8n. Okay, so why? Because the number or the original number will be multiplied by 8. So that's why you will come up with 8n. Then after that is the next solution after multiplying the number by 8. So the next one, class, is add 6 to the product. Okay, so meaning we're dealing with the product, which is 8n, and then after that we will add it by 6. So meaning you will come up with this. It will become 8n plus 6. Then after adding the product by 6, and then the next one, we will divide the sum by 2. Again, we will divide the sum by 2. So meaning we're talking about the sum of 8n plus 6, and then after that we will divide it by 2, and then it will become just like this. It will become 8n plus 6, which is that is the sum, and then it will be divided by 2. So you will come up with 4n plus 3 because 2 is the common denominator of 8n plus 6. So just simply divide. So 8n divided by 2, you will come up with 4n, and then plus 6 divided by 2, you will come up by 3. And then the last procedure is just simply subtract it by 3. So meaning the answer or the previous answer should be subtracted by 3. So you will come up just like this. Okay, so the last answer is 4n plus 3. And then again, we will subtract it by 3. So that's why you will come up with 4n plus 3 and then minus 3. So that's why the answer will become 4n. Okay, so that is the answer for this procedure, which is this example, again, is from the general conclusion going to a specific conclusion, and then we will come up with what we call the logical truth, which is 4n. Okay? Now, after that, so let us proceed to the next. Okay? So that is what we call the mathematical intuition. Okay? So if we say mathematical intuition, so it is coming across a problem, glancing at it, and using your logical instinct to pull out an answer without asking further question. Again, if we say mathematical intuition, so we will come up with, again, what we call this one. Okay? That is logical instinct. Now, so based on mathematical intuition, for us to understand further, so we have here the example. Okay, so example, if you look at the number set with that range or with the range which is between 53 and 73, comprising of the numbers which is 53, 64, 63, 61, 65, and 73 respectively. And whereas to calculate the average, then so first you will first guess will be around 63 to 65 mark. So meaning again, if you take a look at the example, so we will come up with the range between 53 and 73, and then comprising the numbers which is 53, 64, 63, 61, 65, and 74, and we will ask to calculate what we call the average. Okay, so that's why our first guess is 63 to 65 mark. Now, how can we deal with this kind of answer, 63 to 65 mark, even though without using any solving for this example? Now, how can we deal with this? Okay, so first how? Okay, second, so there is one number below 60s, that is 53. Then next, there is one number above the 60s, which is 73. Then another class. So these two numbers virtually cancel each other out. So meaning we need to cancel out 53 and 73 because we know that 53 is the lower range and 73 is the upper range. So that's why we will cancel out those two numbers because we need to find out what is the average of the range 53 to 73. So that's why we will cancel out the lower and upper range. Then after that, every other number is in the 60s with 61, 63, 64, and 65. So the average must be around 63. And the last one, all of this happens in less than a second. This is a mathematical intuition. So meaning we will deal with this process without using any solving technique. Because again, mathematical intuition is we focus on what we call a logical instinct, or just simply we conduct a what we call logical guess. Then we deal with this kind of process. Okay? Then now, how about what we call the certainty? Certainty in math, this one is something that is accurate and absolute. So meaning if we say certainty, so again, something that is accurate or just simply very close to the original value, or an absolute, if we say absolute, so again, that is a definite value or a true value. Okay, so meaning that is the difference between the certainty and the mathematical intuition. So again, mathematical intuition, so we're dealing with the logical instinct or logical guess. But in certainty, so we're dealing with the a value which is accurate and absolute. Okay? Now, let us proceed to the lesson 2. So lesson 2 is a problem-solving strategy or problem-solving strategies. Okay? So for that, so we have here a person which is, he promulgated these steps or the process for the problem solving. So he is George Polya. George Polya was a Hungarian who immigrated to the United States in 1940. His major contribution is for his work in problem solving. He created a famous four-step process for solving or for problem solving, which is used all over to aid people in problem solving. So we have here the steps located below. So if you take a look the steps, so that is these steps are based on based on George Polya. He created these 4 steps. So the first one is understand the problem. Second one is devise a plan. If you say devise a plan, so meaning we will translate the what we call the verbal phrase or the sentence. And then another is carry out the problem or just simply solve. And the last one, again, we need to look back, or just simply if you say look back, we need to check and interpret again the problem. Okay, so for that, so let us apply this 4-step process for problem solving based on George Polya for us to understand this 4 steps. Okay, so let us proceed. So let us try this. Okay, so number 1. So twice the difference of a number n1 is 4 more than the number. Then find the number. So this one is an example of verbal phrase that we need to solve. And then we will apply the problem solving process based on George Polya. So for that, so let us apply that first. Step number 1. So again, that is understand the problem. So to understand the problem, so since we have here again, twice the difference of a number and 1 is 4 more than that number, then find the number. So for step number 1, so we will represent the number as variable x for us to know what is this number. Okay, so that's why we will represent x as the number. Okay, so that is the first step for this problem solving under or based on George Polya. Second step, we have here devise a plan or just simply translate. So again, we will translate twice the difference of a number and 1 is 4 more than that number. To translate this verbal phrase into what we call the variable expression, so first we need to understand again, and at the same time we need to analyze also. So if you notice, we have here twice the difference of a number and 1, meaning difference dealing with number and 1. and then we will multiply it by 2 since we come up with the word twice. And then we have here the interpretation of 2 multiplied by x minus 1 equals x plus 4. So why is it that it is equivalent to x plus 4? Because after reading twice the difference of number and 1, again, we have here the word is. Is represented by the sign equal. So that's why is equivalent to the mathematical or variable expression that is equal, which is 4 more than that number. If we say more than, that is, we're talking about the operation that is addition. So meaning 4 more than that number, so you will come up with x plus 4. So meaning the interpreted equation is 2 multiplied by quantity x minus 1 equals x plus 4. Okay? Then after that, let us proceed to step number 3. Step number 3 is to carry out the problem. So meaning we will solve the problem. Okay, so for that, so again, the interpreted equation is 2 multiplied by quantity x minus 1 equals x plus 4. Then after that, we will do what we call distributive property. We will apply distributive property to 2 times x minus 1. You will come up with 2 times x. It will become 2x. And then we will come up with 2 times negative 1. It will become negative 2x. So 2x minus 2 equals x plus 4. Then after that, in the third line, we will transpose variable x from or going to the left. This x, so we will transpose this going to the left. So you will come up with the third line, 2x minus 2, and then minus x equals 4. And then after that, so combine similar terms, which is 2x and negative x. So that's why we will come up with x minus 2 equals 4. And then in the next line, in the fifth line, we will transpose negative 2 to the right side for us to change the sign at the same time for us to combine similar terms. So that's why it will become x equals 4 plus 2. Then the final answer for this problem is x equals 6. Okay, so the answer is x equals 6. Then after that, based on George Polya, so you will again look back, check, and interpret. So meaning we will check if our translation from verbal phrases or from verbal phrase going to variable expression is correct. And then if the translated variable expression going to or variable or from the verbal phrase going to variable expression is correct, so meaning we will come up with what we call solving. And then let us check if our solving is correct for us to have the final answer, which is x equals 6. Okay, so for that, maybe let us proceed to another example for us to understand further. Okay, so maybe let us proceed to example number 2. This one. Example number 2, so the difference of thrice a number and 4 is equal to 8. Again, the difference of thrice a number and 4 is equal to 8. So again, we will apply the 4 steps of George Polya, which is under the problem solving process. So again, step number 1, understand the problem, and then we will again let x as represents the number. Okay, since x is x is the number, so and at the same time x is also represented for us to get the final answer. Okay, then after that, step number 2, so devise a plan or just simply translate the verbal phrase, which is again the verbal phrase is the difference of thrice a number and 4 is equal to 8. Now if you analyze that, step number 2, so again the difference of thrice a number, if we say thrice a number, it is equivalent to 3 times x. And then again, the difference of thrice a number and 4. So we're talking about difference in the word n. So meaning, if you interpret that into a variable expression, it will become 3x minus 4. Okay? Then is equal to 8. So meaning, if you interpret this all sentence, you will come up with 3x minus 4 equals 8. Okay, so that is our variable expression for us to solve this problem. Okay, then after that, so let us proceed to step number 3. Step number 3, so again, carry out the problem or just simply solve it. Okay, so for us to come up with the final answer, so again, 3x minus 4 is the interpreted equation. Then after that, we will transpose negative 4 to the right side for us to combine similar terms. It will become 3x equals 8 plus 4. Then you will come up with the third line, 3x equals 12. Then after that, to get x, so just simply divide both sides by 3. Okay, so just simply divide both sides by 3 or just simply just like this. So divide both sides by 3 for us to retain the variable x. So just simply divide it both sides. You will come up with the value for x equals 4. Okay, so just simply 12 divided by 3. So the answer for x equals 4. Then again, after you got the final answer, so again, you will proceed to step number 4 and just simply check if your translated verbal phrase or sentence is correct. And then after that, you will check also step number 3 if your solution is correct for us to have a correct final answer. Okay, so that is the process or the problem solving process based on George Polya. Okay. Now, so I think for that, so that is the last part of our discussion. So thank you so much and have a good day to all of you.
For more ICCT College's video updates, please subscribe and click the notification button.